Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. A problem in path of an object in calculus regarding generally calculus 2 or calculus 3 regarding, the position function in t, not x, but t. Let's do it. Index 8 to get to my menu, of course. I'm already at path of an object. I'm going to choose that. Remember, we have to press alpha before you enter anything in these entry lines here. And the problem is alpha minus 16 times t squared plus 40 times t plus 30. I always show you what you've entered. You can change it if you want. Let's discuss this a little bit. Minus 16 t squared, that means that we're dealing in feet. 9.8 meters per second squared, which is acceleration, is 32 feet. Okay? And you integrate 32 feet one time, and you get 16 t. It has to be a minus because so that the trajectory is up like this and over, up and over like this. If there were no minus sign here, it would be like a valley. Okay, so there always needs to be in a function regarding path of object, a minus sign at the beginning. Okay, this here is velocity, 40 feet per second, really. And this is the height you're starting at, which is 30 feet above the ground. Okay, so keep that in mind when you're doing these. These are all setup problems. They don't happen, well, they might happen once in a while in real life, but very difficult because you don't know the velocity. Velocity you have to experiment with to get velocity. But it's in the function, and then of course calculus can deal with it, which is the second derivative. So anyways, let's move on. Say it's okay, and now we have all these things that we can do here: distance at time, height at time. Some problems say distance at time, so I put this in here for students that might say, oh, they're asking for distance. Well, distance is really the height. So I'm gonna press number 2, and we're gonna go. It's the height at a time. We're gonna put maybe alpha 8 seconds in here. I will show you what you've entered again. Say it's okay. And at 8 seconds, the height is, you're going to plug that into the original function here. And it's a minus 674 feet. Okay. Notice that would be below ground, so it really wouldn't happen because minus 64 is you have the arch like this, and then at, what do we got? 8 seconds, so you're on the x-axis, 8 seconds all the way over here, and then all the way down, you finally get to 674 feet. So kind of knucklehead problems here. We're going to find more. We want to find more, so we're going to press 1 here. And we're going to have, what's the maximum height on it? We're going to press number 4. And we find, by doing the second derivative here, or the first derivative, notice when we set that equal to 0, the first derivative is the slope of a line, right? So when you set it equal to 0, it's a horizontal line. Horizontal line, okay? And so that's going to choose the peak of any function on when graphing, because it touches at only one single point. And so we can find that we can solve this for the t, and t is equal to 1.25 seconds. So we know the time of that. We can plug that into the original function here, and it comes up to 55 feet. That's the maximum height. We're going to find more. Let's go with the time it hits the ground, number 6. Of course, when it hits the ground, the height is 0. There's no footage at all on the ground. So you set the original function equal to 0, then use the quadratic formula to find the, which I do for you. Write this on your paper, you look like a genius. And then it comes up with minus 0.604 and 3.1. Generally we use the positive values for x, which is really t, but I have to use my program for quadratic formula in which it deals in x's. So the positive is used t equals 3.1 seconds when it hits the ground, okay? So anyways, I'm going to do a couple more of these problems here, so look for my more videos. Hey, have a good one. Go to my site, buy my programs, and pass calculus. Bye.